Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, you all know that in the last class we were revising midterm syllabus. In mathematics, the first three chapters were revised and the fourth one was started, right? Now let's go for continuing this. In this chapter, first we come across the definition. What is the definition? Yes, an equation of degree 1 with two variables is called linear equation in two variables. Then what is its general form? It is ax plus by plus c equal to 0, where a and b are not equal to 0. Then how many solutions does a linear equation in two variables have? Very good. It has infinitely many solutions. Hence, we learned how to find out the required number of solutions for the given equation. Then after that, we have also verified whether the given numbers are the solutions of given linear equation or not. Next, in the next part of this chapter, we come across drawing the graph of linear equation in two variables. Now, could you tell what is the nature of graph of this equation? Yes, it is a straight line. In that, two were discussed. Now, I am going to take third one. In third one, the question is like this. Draw the graph of, you can also write with me, graph of, it is 2x minus 3y equal to 10. Then how do you go for drawing the graph? We know that before going to draw the graph, first we find out coordinates of a point. Coordinates. First, write the given equation and solve y. 2x minus 3y is equal to 10 is the given equation. 2x, transfer 10 to the left hand side, minus 10, minus 3y to the right hand side, plus 3y. Then 2x minus 10 by 3 is equal to y. This is the y. Y has been written in terms of x. Using this, we have to find out coordinates of some points. Minimum 3 points are required. So we will go for calculation table. In that, first column is for x, second column for the equation, that is y equal to 2x minus 10 by 3, and third column it is for x comma y. Now choose the value for x. If you go for taking 0, see that 0 in place of x, it will be 0 minus 10, minus 10. Minus 10 is not divisible by 3, cannot be taken. You may take 1. When you take 1, 2 ones are 2. 2 minus 10, minus 8. Minus 8 by 3, not divisible. Next, take minus 1. 2 into minus 1, minus 2. Minus 2 minus 10, minus 12 is divisible by 3. You can take minus 1. Then y is equal to 2 into minus 1 minus 10 by 3. It is equal to minus 12 by 3 is equal to minus 4. Minus 1 comma minus 4. Next, if you go for taking 2, observe it, 2 2s are 4. 4 minus 10 minus 6, which is divisible by 3. So let us take 2. So y is equal to 2 into 2 minus 10 by 3 is equal to 2 2s are 4, 4 minus 10 minus 6 by 3 is minus 2. So 2 comma minus 2. Then let's go for taking one more number. If you take minus 2 in place of x, it will be minus 4, then minus 10, minus 14, which is not divisible by 3. Take 3. 2 3s are 6, 6 minus 10 minus 4 by 3, not divisible. Take minus 3 into 2, minus 6 minus 10 minus 16, not divisible by 3. Then go for 4, 2 4s are 8, 8 minus 10, it is minus 2, which is not divisible by 3. Take minus 4, 2 into minus 4, minus 8 minus 10 minus 18, divisible by 3. Let us go for taking minus 4. So then y is equal to 2 into minus 4 minus 10 by 3. It's equal to minus 18 by 3 is equal to minus 6. So it is minus 4 minus 6. And you can name these coordinates point as A, B and C. You may draw the graph. That is, you will draw x and y axis, then go for marking all the 3 points, join them, you will get a straight line. Followed? Now this is the third example. In the next type, we will convert some of the statements into equations, and for that we will go for drawing the graph as well. I will take some examples with respect to them. Dear students, go through this heading. Drawing the graph for the following situations. Here some situations will be given. Those situations should be converted into equations. Then for those equations we can draw the graph. Here I will take few of the situations. First one very simple. I am not going to write. Let me read and listen carefully. Using that statement, let us form this equation. Yamini and Fatima, two students of class 9 of a school, together contributed rupees 100 towards the Prime Minister Relief Fund to help the earthquake victims. Then write a linear equation which satisfies this data. Is it not simple? Yes. Here there are two students. One is Yamini and another one is Fatima. Both will contribute rupees 100 towards the Prime Minister's Relief Fund. But we do not know what amount contributed by Yamini as well as Fatima. You can go for assuming that it is let the amount contributed by Yamini. How much? It is rupees X. And similarly, the amount contributed by Fatima, you may call this as Y. What is the total amount contributed by them together? It is 100. Here I will write total contribution is rupees 100. Then from this statement we can write amount contributed by Yamini and Fatima, that is equal to 100. X plus Y equal to 100. Followed? And this is the required equation. For this equation we have to draw the graph. To draw the graph, what is the first step to be followed? Very good. We should solve Y, or we should write Y in terms of X. How? So Y is equal to 100 minus X. Got it? Then choose some values for X and find out Y. But here, as they have given the situation related to amount contributed, that's why here X, in place of X, no need to go for taking 1, minus 1, 0 and down. Take 10 rupees or 20 rupees, 30 rupees, 40 rupees, 50 rupees like this. Got it? Okay. Next, let's go for another situation. Second example. Again from this NCERT text, listen carefully. This is also very important in the examination point of view. The statement is, the taxi fare in a city is as follows. For the first kilometer, the fare is rupees 8. For the first kilometer, the charge is rupees 8. And for the subsequent distances, it is rupees 5 per kilometer. Taking the distance covered as x kilometer and the total fare as y rupees, write a linear equation for this information and also draw the graph for this. Hope that you all have understood this. Here they are given the taxi fare. Taxi fare. How? For the first kilometer, the fare is rupees 8. Fare, nothing but charge. For first kilometer, it is rupees 8. And fare for the subsequent distances, for the remaining distances, it is rupees 5 per kilometer. Fare for subsequent distances, it is equal to rupees 5 per kilometer. Followed. Here they have asked you to take distance covered as x. Total distance as x, and the total fare, total charge as rupees y. Then how do you convert the situation into equation? Look here. They have given for first kilometer 8 rupees. 1 kilometer for first kilometer. For next remaining, what is? Could you tell? What is the distance remaining after 1 kilometer? So total distance is x. In that already for first kilometer it is fixed. Remaining distance will be, it is x minus 1 kilometer. Followed. For first kilometer how much the charge? It is 8. Then for remaining 5 rupees per kilometer. So here x minus 1 kilometers are there. So 5 into x minus 1. Then total fare as y. Got it? So this has been written by using the statement. From the statement we can write y equal to fare for first kilometer plus and fare for remaining distances. It is equal to 8 plus, multiply 5 with both the terms, 5 into x 5x, 5 into 1 5. It is equal to 5x. 8 minus 5 is 3. Y is equal to 5x plus 3. So this is the required equation. And for this equation, first you have to find out coordinate points. How do you find out the coordinate points? Look here. It is better to take tables 5. It will be easier. When x is 5, 5 5s are 25. 25 plus 3, 28. Then 10, 5 10s are 50, 10 5s are 50, 50 plus 3, 53. Others 10, 15, 20, 25 like this. This is the way you can find out coordinate points for this equation. After that, draw the graph. Got it? Let me go for taking another example. You may just go for copying as it is. Now, next we shall move on to third one. It is also another important statement. Is like this. If the work done by a body on application of a constant force is directly proportional to the distance travelled by the body. Right? Express this in the form of an equation in two variables. Hope that you all have understood this. And this is the situation related to work done. When do you say a body has done the work? Very simple. When force is applied on a body, if it displaces, then only we can say that work is done. Then we are very familiar with the formula of work done, that is W equal to F into S. They have given, if the work done by a body on application of constant force is directly proportional to the distance travelled by the body, work done is equal to, work done is directly proportional to distance travelled by the body. Here, let us take the work done by the body as it is y. Then, distance travelled by the body. Distance travelled by the body, that is x, or you may write x unit, here also y unit. Then work done is given by, then we can write W equal to F into S. Now here they have asked you to draw the graph of the same by taking the constant force as 5 units. So here they are given force is 5 units. Here only I write. Force is equal to 5 units. Then W equal to Y, force is 5, S is, that is distance travelled is X. Y equal to 5x. Got it? So this is the equation. And for this equation, you have to draw the graph. How do you draw the graph? By finding the coordinates of points. Find any two or three coordinates. See, first you will go for taking 5 in place of x. 5 5s are 25. Then 10 in place of x. 10 5s are 50. 15 in place of that. So 15 5s are 75. Or else 2 units, 4 units, 6 units. If you take 2 in place of x, it will be 10. Y equal to 10. When x is 2, y is 10. 4. When x is 4, y will be 20. Then for that you can draw the graph. Followed? And do remember, this is the equation in the form of y equal to constant into x. Do remember, the graph of y equal to constant into x always passes through the origin. Again, we will discuss about it in the later part. Let me go for taking another example. This is also very important. Example number 4. This is related to temperature or conversion from one scale to another scale. The statement has been given like this. In countries like USA and Canada, temperature is measured in Fahrenheit. Whereas in countries like India, it is measured in Celsius. Here is a linear equation that converts Fahrenheit to Celsius scale. That is, degree Fahrenheit is equal to 9 by 5 degree Celsius plus 32. Now the question is given like this. First one, draw the graph of the linear equation above using Celsius for x-axis and Fahrenheit for y-axis. Okay, then we can rewrite this equation as, see, Fahrenheit, it should be taken along y-axis. So y is equal to, this is 9 by 5. Celsius scale is to be taken along x-axis. So it is x plus 32. Then to draw the graph for this equation, again you have to choose the values for x. How do you take x values? Yes, it is better to go for taking the multiples of 5 because it will be easier to cancel. If you take 0, okay, it will 9 by 5 into 0, 0. 0 plus 32, 32. When x is 0, y is 32. Next, when x is, no need to go for taking 1. Instead, take 5. If you take 5, 5 and 5 get cancelled, 9 will remain. 9 plus 32, 41. When x is 5, y is 41. Next, take 10. Then 5. 5 ones are 5 twos are 9 twos are 18. 18 plus 32, it is 50. Clear now? So when x is 10, y is 50. Like that you may take 15, 20 and so on. Any 3 points are enough. Then after finding the coordinate points, go for drawing the graph. Followed? Okay. These are some important statements. And in this regarding fourth one only, we have some more sub questions like this. If the temperature is 30 degrees Celsius, what is the temperature in Fahrenheit? Either they may expect calculation or they may ask you to find out that by using the graph. Okay. If they ask you directly with a calculation, that is, here temperature is given in degree Celsius, 30 degrees Celsius, then it should be converted into Fahrenheit. It is y is equal to 9 by 5 into 30 plus 32. 1s are 6 are 9 6 are or 6 9s are 54 plus 32 is equal to 86. Then we can write 30 degrees Celsius is equal to 86 degree Fahrenheit. Got it? Next. In the third sub question is like this. If the temperature is 95 degree Fahrenheit, what is the temperature in Celsius? Very simple. Temperature is given in Fahrenheit. It is 95 degree Fahrenheit. Use this formula. So 95 is equal to 9 by 5 into x plus 32. Transfer 32 to the left hand side. 95 minus 32 is equal to 9 by 5 into x. Then subtract. 5 minus 2 is 3. 5 minus 3 is 6. Then cross multiply. 5 then 9. It is equal to x. Here 3 3s are 9, 3 2s are 1s are. X is equal to 21 5s are, or else you may cancel it. 1s are 7s are, 7 5s are 35. So therefore we can write 95 degree Fahrenheit is equal to 35 degrees Celsius. Next, fourth sub question is like this. If the temperature is 0 degrees Celsius, what is the temperature in Fahrenheit? Very simple. Temperature is given in Celsius. It is 0. If it is 0, 9 by 5 into 0 is 0. 0 plus 32, 32. So then it is equal to 32 degree Fahrenheit. And if the temperature is 0 degree Fahrenheit, 0 degree Fahrenheit, okay, if it is 0, then you may cross multiply, transfer 32 to the left hand side. It becomes minus 32, minus 32. It's equal to 9 by 5 into x. Then cross multiply. Minus 32 into 5 by 9 is equal to x. 35, 32 5s are, 5 2s are 10, carry 1, 5 3s are 15, 16 by 9. It is x. Then cancel it. It is equal to minus 9 1s are 9. 7 will remain 70. 9 7s are 63. 7 will remain 70. 7s are 7s are. So it will be minus 17.77. Followed? Minus 17.77 degrees Celsius. Next, one more. This is very important. Fifth sub question is like this. Is there a temperature which is numerically the same in both Fahrenheit and Celsius? If yes, find it. Of course, there is a temperature at which Celsius scale and Fahrenheit scale are equal. You all know that. Could you tell what is the temperature? Yes, very good. It is minus 40. But how to get that minus 40? Once I explain that. And before going to that, just go for copying this. Let us find out that. Here, let us take degree Fahrenheit is equal to degree Celsius equal to x. And we all know that degree Fahrenheit is equal to 9 by 5 into degree Celsius plus 30. Substitute x in place of f and c. It is x equal to 9 by 5 into x plus 32. Then transfer 32 to the left hand side, becomes minus 32 is equal to 9 by 5 into x. Cross multiply 5. 5 into x minus 32 plus, that's equal to 9x. Multiply by 5. 5 into x, 5x. Minus 32 5s are, 5 2s are, 10 carry 1, 5 3s are 15, plus 1, 16, 160. This is equal to 9x. Then minus 160 is equal to 9x. Transfer 5x to the right hand side, becomes minus 5x. This will be 4x is equal to minus 160. X is equal to minus 160 by 4. 1s are, 4s are. So x equal to minus 40. That means, here I will write, minus 40 degrees Celsius is equal to minus 40 degree Fahrenheit. Hence, you can say that there is a temperature at which Celsius scale and Fahrenheit scale both are same. That is minus 40. Got it? So these are the statement problems related to the graph. Next, now we are moving to the particular type of, the particular graph for some different equations. Let's go for writing them. Dear students, observe. Here we have 4 different types of equations. For these equations, we have to draw the graph. Okay. First one is y equal to constant into x. It may be y equal to 3x, maybe 5x, 7x, or 8x, and so on. Anyone in it may be. When you draw the graph for this equation, you will get a straight line, but that straight line will pass through the origin. Should be remembered. Now, could you tell the quadrants through which the graph of this equation passes through the origin, either first and third or second and fourth. Very good, it is first and third, because see that y equal to constant into x is there. If you take positive values for x, both will be positive, and if you take negative, both will be negative. Clear? So plus plus minus minus. Hence the graph of y equal to constant into x passes through origin through first and third quadrants. Remember this. Can be asked in the examination. Which of the following graphs will pass through the origin? Like this, y equal to constant into x, then y equal to x plus 2, or x plus y equal to minus 10, and so on. Like this it can be given. Once I repeat, y equal to constant into x. This is the equation. The graph of this equation, it will be a straight line, and this will pass through the origin, and the quadrants through which the graph of the given equation passes through the origin are first and third. Next, go through second one. Y equal to minus constant into x. I'll take an example. Y equal to minus 2x or minus 7x or minus 10x and so on. Look here. If you take positive value, when x is positive, then y will be negative plus minus. If x is negative, y will be positive. Followed? So we will get plus comma minus and or minus comma plus. Then how will be the graph? No doubt the graph of the given equation will be straight line, but it passes through origin. I have already told you the graph of y equal to constant into x, it may be positive or negative. It passes through the origin, but the quadrants will be different. If it is minus constant into x is there, it passes through the quadrants second and fourth. See that this is second quadrant and this fourth quadrant. Followed? Next, third, y equal to just a constant, no other variable is there. Then do remember, the graph of this equation will also be a straight line, but this will not pass through the origin. Instead, y equal to constant, it is always parallel to x-axis. Right. See, this is y equal to constant, and if constant is 5, y equal to 5, then look here, we have to mark the point 5 on the y-axis, and there we have to draw a parallel line. Got it? If y equal to constant, it is parallel to x-axis. If y equal to minus constant, then again it will be parallel to x-axis only. But only the difference is, if it is the constant is positive, the graph of the equation will be above x-axis. If it is negative, it will be below x-axis. Or if you want to name the quadrant, see that y equal to positive constant passes through the quadrants first and second. Next, y equal to minus constant, it is parallel to x-axis, but it passes through third and fourth quadrant. Got it? Next, fourth one, x equal to constant. Then to draw the graph of this, again we will go for taking x and y axis. X axis is denoted as xo x dash, y axis is denoted as yo y dash. X equal to constant, please do remember, it is always parallel to y axis. See that? It is x equal to constant. and the quadrants are first and fourth. If it is x equal to minus constant, again it is parallel to y-axis, but passes through the quadrants second and third. Got it? Please do remember all four. They are all very important. Once I repeat them. If y equal to constant, it passes through the origin. If that constant is positive, it passes through the quadrants first and third. Then if it is negative, passes through second and fourth. If y equal to only constant, then it is parallel to the x-axis. If it is positive, passes through the quadrant first and second. Negative, passes through the quadrants third and fourth. If x equal to constant, then the graph of that equation will be parallel to y-axis. If it is positive, passes through first and fourth. If it is negative, passes through the quadrants second and third. Chance of giving this in the examination for 1 mark. Yes, you may go for copying this. Dear students, please go through this. This is another important and the last concept of this chapter. We will go for representing some of the equations. By solving them, we will represent them on the number line as well as in the Cartesian plane. Let's come to know that. One such example is that solve the equation 2x plus 1 equal to x minus 3. That should be solved. Okay, let's go for solving this. It is 2x plus 1 equal to x minus 3. Then transfer x to the left hand side. It becomes minus x. 1 to the right hand side. It becomes minus 1. What is 2x minus x? It is 1x. Minus 3 minus 1. This is minus 4. X equal to minus 4. Next. And we have to represent this solution on the number line as well as on the Cartesian plane. If it is on the number line, very simple. There is minus 4. Draw a number line. Draw a straight line and go on marking for every unit distances. You may take 1 centimeter. It is 1. This is 2, 3, 4 and 5. Here on the left side of 0, the numbers are negative. Negative 1, negative 2, negative 3. Then negative 4, negative 5. But what is the value of x? X is minus 4. Here, you can just represent that with a box. This is the way of representing the solution on the number line. Now it should also be represented in the Cartesian plane. If it is in the Cartesian plane, there must be two axes. One is the horizontal line called x-axis and the vertical line is called y-axis. X-axis is denoted by x over x dash, y-axis is denoted by y over y dash. Both will intersect at a point at right angle, which is origin. And we also know that right side of 0 are positive. Here I write 1, 2, 3, 4, 5. Left side of 0 are negative. It is minus 1, minus 2, minus 3, minus 4, minus 5. Because here minus 4 is given. Above 0 are positive. It is 1, 2, 3. And below 0 are negative. Negative 1, negative 2, negative 3. Okay, here x equal to minus 4 is there. It is nothing but x equal to constant. If x is equal to constant, as we know that it is always parallel to y-axis. X equal to minus 4, parallel to y-axis. So through minus 4, we have to draw straight at point minus 4. See, this is x equal to minus 4. Followed? It is very important in the examination point of view. Please do practice. Okay. So this much is related to the chapter linear equations in two variables. Dear students, now we are moving to another chapter, that is Introduction to Euclid's geometry. Yes, copy this. Dear students, now let's go for revising the chapter Introduction to Euclid's Geometry. Here also we have some important concepts. We have already learned them. Let's go for recalling. The very first one, here we know that many civilizations have contributed a lot of information to the field of geometry, right? But among them, one is the Greek civilization. They had found out the volume of truncated pyramid, right? Then how will be the truncated pyramid? Of course, it is a pyramid in which two squares are parallel to each other and other lateral surfaces will be trapezium shape, right? Here I am going to draw that. You can also write with me. It is truncated pyramid. Truncated pyramid. You can draw like this. Here is a square. This is square. And go for drawing one more square here. And call each side of big square as A. Then each side of small square as B. Then join consecutive vertices like this. Then here mark the midpoint of both the squares and join them. This is height of the pyramid. This is what we say truncated pyramid. Followed. Next, as I told you, many civilizations has contributed lot of things to the field of geometry, but among them, one of the civilization which was very well developed, very well organized, which is that? Yes, it is Indus Valley civilization. Indus Valley civilization. So, is there any examples to say that Indus Valley civilization, it was very well developed and organized society? Yes, there are some examples. They had built the houses having different types of rooms. Houses having different types of rooms. Then, second point, there was underground drainage system. There was underground drainage system. Next, third one, yes, whatever the roads were there in that time, all the roads were parallel to each other. Roads were parallel to each other. And whatever the bricks they were using, in that time only they were using the burnt bricks, and these bricks had the dimensions 4:2:1. So bricks were having the dimensions in the ratio, that is length into breadth into height. Dimensions L/B/H is equal to 4:2:1. These are the few examples to say that Indus Valley civilization was very well organized society. Next, even our Indian civilization has also given a lot of contribution to the field of geometry. Let us take some of the examples. In that time only, they had made a manual for geometrical constructions. Then what do you call that? The manual. Yes, it is right. That is Sulba Sutra, right? Here, you may copy with me. Indian civilization. In that first one is, it is Sulba Sutra. What it is? It is a manual for Manual for geometrical constructions. Means in that time only they were using many geometrical figures like trapezium, rectangles, squares, then circles and all. And for drawing the geometrical figures or geometrical constructions, they were using a sacred thread which is called altars. Altars, A-L-T-A-R-S, which is a sacred thread. Sacred thread used for geometrical construction. Used for geometrical constructions. Then in the geometrical constructions they had made two categories, one for household rituals and another one for public worships. Let me give you both of them. For household rituals, they were using two geometrical figures. One is square and another one is circles. Next, for public worships, they were using other geometrical figures like a rectangle. See that opposite sides are equal. This is rectangle. Even trapezium, a quadrilateral in which one pair of opposite sides are parallel. Not only this, even they were using triangles as well. Can be asked in the examination. Okay. Name the geometrical figures used in the Indian civilization for household rituals. You have to write squares and circles. Then for public worship, rectangles, trapeziums and triangles. Then another important one, we are very familiar with isosceles triangle. So there were a combination of 9 interwoven isosceles triangles like this. So here just I am showing only 2 like this. Total 9 were there, and we call this as Sri Yantra. S-R-I-Y-A-N-T-R-A. Sri Yantra. It is a combination of 9 interwoven isosceles triangle. Combination of 9 interwoven isosceles triangles. Followed? Yes. Please go for copying up to here. Dear students, in geometry, do you know who has given the first proof for the statement? And which is that statement? Very good. This is a Greek mathematician. He is Thales. Then what was that statement? Very good. It is a circle is bisected by its diameter. Please do remember, this is the first statement for which the first proof was given. Statement is a circle is bisected by its diameter. No doubt. That means a diameter of a circle will divide it into 2 equal parts. Each equal part is a semicircle. Okay, this is the circle with center O, and this is the line joining any 2 points on the circumference of the circle passes through the center, and this is called diameter. AB is the diameter. It will divide circle into 2 parts. One is AXB and another one is AYB. Followed? Here I'll write. AB is the diameter. Then AXB as well as AYB. These two are semicircles. Next, this proof was given by a Greek mathematician. Who is he? Very good. Thales. Greek mathematician. Thales. T-H-A-L-E-S. And his pupil, nothing but his student, Thales' student, is also one of the familiar and famous mathematician is Pythagoras. Pythagoras and his followers, nothing but his pupils, are nothing but, they are also called Pythagoreans. Pythagoras and Pythagoreans, they had given lot of information to the field of geometry, and all these were summarized by another mathematician. He is Euclid. Yes, he is Euclid. What all the information was there related to geometry, all were gathered by Euclid, and he has made a famous treatise, and this is called Elements. And in his Elements there are 13 chapters. 13 chapters, and each chapter is called a book. It is called a book. Dear students, even in this chapter we have also come across famous Euclid's definitions, axioms and postulates. Now let us go through them. Euclid's definitions, axioms and postulates. Yeah. Now could you define definition? Nothing but, what is the definition for definition? That is, definition is a verbal statement of a geometrical figure. Once I repeat, a verbal statement of a geometrical figure is known as definition. For example, how do you define a square? Square is a quadrilateral in which all sides are equal and each angle is 90 degree. Got it? Square can also be defined in another way as a rhombus in which each angle is 90 degree is called a square. Next, axiom. What are axioms? Axioms. Definition of axiom. It is an elementary statement, nothing but basic statement, fundamental statement, which can be accepted without logical proof. Once I repeat, an elementary statement which can be accepted without any logical proof is called axiom. Give an example for that. Very good. If you half of equals are equal, or else whole is greater than its parts. For example, when you go for taking the line segment AB, and when you can go for cutting to number of parts, like see that the parts are AP, PQ and BQ. The whole, that is AB, which is greater than AP, AB is also greater than PQ, AB is also greater than BQ. So whole is greater than its parts. Next, one more, postulate. How do you define postulate? It is also an elementary statement which can be accepted without logical proof but with construction. An elementary statement which can be accepted without logical proof that can be verified with construction is known as postulate. Give an example for postulate. Yes, a terminated line can be extended on either side to any distance, or else one and only one line can pass through two given points. Look here, I'll go for marking 2 points on this plane. Call these points as AB. Could you tell how many lines can pass through both the points? Yes, one and only one line. Here I am drawing. See that. This is a straight line. One and only one line can pass through two given points. So we have many definitions, axioms and postulates. Let's go for learning them. Please go for copying from there to here. Dear students, hope that you have copied. Now, let us go for learning in detail about definitions, axioms and postulates given by Euclid. And today, what all the what are the concepts we have revised. Please do practice them today itself without fail. And in next class, we'll go for continuing this chapter.